I'd like to take a moment to thank today's video sponsor, Destiny Solutions, a Penn, Ohio social media sponsor. Quality products at a competitive price. Check them out at destinysolutions.us. Hello again, Penn, Ohio family. I'm extremely thrilled today to sit down with John Deegan, Senior Sales Engineer at Ruckus, to talk about Wi-Fi. I've been excited about this one for a long time because John is very knowledgeable, but he's also very entertaining when he talks about Wi-Fi. John hosts the Ruckcast with Jim Palmer on a bunch of different platforms. I am a subscriber on YouTube, admittedly a fan, so I'm excited to have John here today. He is a senior sales engineer at Ruckus, as I mentioned, and also a certified wireless network expert, number 341, if you're keeping track. So we're excited to talk about all things Wi-Fi today. So John, thanks for making the time to join us. I'm super excited to have you on our channel, being a subscriber to yours, and to help educate our membership on all things Wi-Fi.
Well, thank you for having me. I appreciate it. I'm happy to be here. And yeah, let's see if I can actually share my screen, and we'll talk about Wi-Fi.
Yeah, while you're loading that up, so the Ruckcast with John and Jim is very funny, but it's also very informative, and they're on all the major channels, including YouTube, Apple Podcasts, Spotify, Overcast, Amazon Music, and Castbox. So if you're looking for a place to get more information on Wi-Fi while being entertained, I would encourage you to check out the Ruckcast. And
in addition to being a CWNE, I'm also a Ruckus Certified Wireless Associate. I teach the class as well. We could talk about that. If anybody wants to find me online and ask questions, feel free. I'm on all the usual socials, and like Michael mentioned, we have a podcast that's out there to be consumed, and we've got 100 or so episodes out there to entertain you, and lots of good informative content. So anyways, I was asked to talk about Wi-Fi, so we might as well actually talk about Wi-Fi. And so we've got some keys that we want to share with you for great Wi-Fi.
Yeah, this is one of those topics that's super deep, John, and it's one of the more misunderstood, particularly in the wireline business that we're in cable television, right? Like we were talking about before, is most of us in this business grew up having a field strength meter that you connected to the network, and you could actually see and measure in the frequency and amplitude domain, like the quality of the signals, where when you get into wireless, it's a much different landscape, and Wi-Fi has become so important and so ubiquitous that it's just one of those things that is one of the top 4 requested trainings from our membership. So that's kind of how we got here. But yeah, let's talk about Wi-Fi.
Sure. So I'm going to basically set the table, and as we're going to talk for a little bit today, everything we're going to go through here is going to build a foundation that we can step into and get a little bit deeper into Wi-Fi. And it can go down quite a rabbit hole above and beyond what we're going to get into today. But as mystifying as Wi-Fi can be, because you can't see all the packets flying around our heads right now, it starts with like any good design. You're building a house, you're building any other wired or wireless network, or anything, like any project, you need to understand the requirements. It is probably the hardest aspect of Wi-Fi. I actually just did one of these for another customer a couple weeks ago. If you don't get good requirements, you're kind of fishing. You're guessing. So you sit down, you talk to your customer, you understand, or even let's start at home, right? I have a customer right here. I'm surrounded by my wife and kids. They're a customer. They have really hard requirements, but you have to understand, what do you need? Where do you need the wireless? How good do you need it to be? Do you want coverage outside? Do you want coverage all through the house, all through the office? Are there very important areas? If it's a small business, maybe it's a doctor's office or a small storefront, maybe there's only part of the workspace that needs the Wi-Fi. They really need to make sure it works best by the point of sale terminal, things like that. So understanding the requirements, it's very important. It's the old saying from many lives ago, right? Garbage in, garbage out. If you get bad requirements in, that's what you're going to be able to put out. And it's no fault of your own, because you didn't necessarily get the good information. But what do they need? Where do they need it? And sometimes it's hard for the customer to articulate it, because as with anything, and it's not just Wi-Fi, it could be cable installation, it could be, you know, whatever. You're going to call them up and say, I just want cable. Okay, but where do you want it? And the reality is you're saying, like, do you want it in all 5 rooms? Do you want it in the middle of the room? Where do you want your TV to be? So you just talk through it a little bit. And the same thing goes for Wi-Fi. You could be in a storefront and they've got, you know, 3 cash registers and they've got wireless terminals on iPads, and they want to make sure that the wireless coverage is really, really good in a certain area. So you make sure that you do everything you can to put the wireless access point closest to that area. Things like that. And make sure that it's what they need. So often we see in everything, I mean, you go to a car dealership and they sell you whatever they can sell you, not necessarily what the customer actually needs. And so that's one of those things where it's just making sure we understand what challenges they're trying to solve. Now, with Wi-Fi, it gets a little bit funky. And this is going to get deep into, we're going to get ahead of ourselves a little bit with Wi-Fi 7 coming, and we'll get to it in a later portion of this presentation. But Wi-Fi has different clients, and the different clients are going to behave differently. And I will say this probably multiple times in this presentation, but in wireless, the client drives everything. So, you know, if you're coming from like, I'm trying to think of a good analogy, but if you're an AV guy, if you like home theater, you've got different connections and you've got your different Dolbys and Atmos and all the different sound things, and I'm not, so it can clearly show that I'm not. But different devices are going to function differently. So in wireless, we've got 2.4 gigahertz clients, we've got 5.8 gigahertz clients, and now, as of very recently, we've got 6 gigahertz clients. We've got some client devices, I should say, that can only function as a 2.4 gigahertz only device. Some examples of that.
iPhone 4?
Yes, you get some of the older devices like iPhones, you can absolutely find those. Other common cases, I'm not going to mention it because I've got one particular one on my desk, but if you go to some of the smart home devices or the streaming devices, the lower budget, Chromecast type things, and this is not a knock on the devices, but when you're looking at a $30 or $40 device that you can get on sale, a lot of those only have a 2.4 gigahertz radio in them. So when you see like the premium devices, part of the premium is you're actually getting a 5 gigahertz chip for quote unquote better Wi-Fi. You'll get some most modern phones, most recent iPhones from the last 5-10 years have 2.4 and 5 gigahertz in them. And I'm not going to be pandering to any particular device other than what Ruckus sells, because it's what I know and love. Just getting that out of the way. And then now, again, as of the last year or so, maybe a little bit longer than that with 6E, we're starting to see 2.45 and 6 gigahertz clients. But each client type will function a little bit differently and has some different requirements. For example, and I'm going to say this very carefully because I don't want to get crucified, 2.4 gigahertz clients, you don't need as much 2.4 coverage in a particular environment. And that's not because 2.4 covers better, it penetrates better. And that's a little bit more of a deep RF conversation, but the wavelengths are different, 2.4 to 5 to 6. So 6 gigahertz penetrates the least good of the three. 5 gigahertz penetrates a little bit better. 2.4 penetrates the best of all in terms of how much signal is left after it goes through a number of walls, which is why, you could be on the edge of a property and you might still see a very weak but usable 2.4 signal, but you won't see a 5 or 6 gigahertz signal because they propagate differently. But again, that's an advanced topic, and you can have us back. We can get into those weeds if you want to.
Yeah, I don't think that one's too alien to us, John, because, even in the cable television, the RF world, the lower the frequency, the lower the attenuation, right? It's just a different medium. That's attenuation as a function of frequency over coax, but free space path loss is the same thing, right?
Exactly.
It's attenuation based on frequency over the path. So, try to explain that one to your mother-in-law, but the lower the frequency, the farther the wave will travel.
100%. And so that's exactly, if you're familiar with that, that's exactly what's at play for us as well. Wired and wireless is no different there. What we get into even more fun with is as we get into the 6 gigahertz clients, some of them are what we will call, and the 6XD and the 6CD comes out of the MAC headers and things like that from the actual packet captures. or if you look at like the FCC ID and the FCC documentation that they file for these devices. But for the purposes of our conversation, we'll call them LPI or dual clients. And so LPI was what 6E operated in when it came out, and what Wi-Fi 7 devices were initially able to work with without AFC. That's low power indoor. These APs are indoor only, and they are by nature, as the name implies, low power. And we'll actually get into this with some spectrum looks in a minute or two. Whereas dual clients can actually work on standard power, which requires AFC, or LPI APs. And so why this is critical as we move into the new world, if you will, the Wi-Fi 7 landscape. And I say move into because it's still very much in its infancy. These two clients, it's very possible to have a client cell phone or a client tablet or a handful of them where some of them are dual clients and are working perfectly fine everywhere in your network. And some of them are LPI only and don't work when you go outside on that outdoor AP that's Wi-Fi 7 that requires standard power. So it's again, the client drives everything. But it's important to know that in that sense, the only way around that is to buy a different client or just have an LPI AP by the window to service that other outlier device. But what I wanted to kind of circle back to is it's important to stress Wi-Fi 7 is where we're going. Looking at the timeline, Wi-Fi 7 was ratified. I'm not even going to put the ratification date because I don't want to get, I don't have my dates in front of me, but it's a thing for about, call it a year. The first Wi-Fi 7 AP enterprise shipped late last year. It may or may not have been a Ruckus AP. We actually have at this point just started seeing outdoor APs with Wi-Fi 7, but the devices and the clients are just starting to come out. The adoption is, as you'd expect for a first wave, if you will. I don't want to say slow. People are very excited about it. I think the general mood about this is very, very optimistic because there's a lot of good things, and we'll get into it, that Wi-Fi 7 brings to the table for Wi-Fi, which we've desperately needed for a while. And I think that the gains are going to be really fun to see. But it is important to stress two things. One, Wi-Fi 7 is definitely, you're an early adopter at this point if you've got one. And 2.4 and 5 are not going away. So if you have it, you don't have to feel a rush to go get Wi-Fi 7. I'd love to sell you some, but that's a separate conversation for a separate day. But 2.4 and 5 are still going to work fine. The spectrum is what it is. It's what it's been. They will still work most of the time for most people. They're going to be perfectly adequate for the day-to-day lives. So there's no like, oh my God, we've got to upgrade. Only if you really need to. If you're buying a new device and it's like the same, I would just say, get Wi-Fi 7 to be future-proof. But it is a really exciting thing that we've got coming down the pike at this point. And I've said it during a number of other sessions and probably on the podcast a time or two. I'm really excited because it's almost like, I don't want to say a rebirth of Wi-Fi, but it really feels like that to me. Like I said, I've been doing this for 10 years and I kind of came in when 5 gigahertz was already a thing. And with Wi-Fi 6 and 6E, it was kind of like 6 was cool, but it wasn't like, it didn't bring as much to the table as this does. And 6E, because it happened during the pandemic, really, it was sort of passed over. I know people bought 6E devices and 6E APs, but the adoption rate for that, I feel, was a lot less because you saw the roadmap and everybody kind of just looked at it and said, okay, forget 6E, we're just going to go to 7. Because with AFC, with all the bits and pieces that come with 802.11be, which is the official classification for Wi-Fi 7, it just made sense. So I think a lot of people kind of held off, and now we're really starting to see people get excited for it. And it is a good thing.
Well, there's some parallels there to the coax space too, right? With the DOCSIS specifications starting from like DOCSIS 1 to DOCSIS 1.1 and 2 and 3, 3.1. And we just, are starting to deploy now DOCSIS 4, which is like massively different than all of the previous iterations, which it's still backwards compatible to all of those. but it's uniquely new, and it enables things like full duplex DOCSIS and symmetrical gigabit speeds and expanded spectrum, high split, ultra high split, like all that stuff. It kind of feels like that. And to the same point, like there wasn't a ton of like crazy expansion in DOCSIS 3.1, even though it allowed for it. The operators didn't really leverage it because they're like, well, DOCSIS 4 is coming, so like we'll really jump feet first into that one and sort of skip over that phase of technological deployment. It feels a little bit like that.
Yeah, no, that's actually a really good analogy. And I hadn't, as much as I work with I have not experience with, but I work with some of the DOCSIS side of things. I hadn't actually made that parallel, but it's actually a really, really good comparison.
Yeah. Oh, so I do have a question. If a Wi-Fi 7 AP falls in the forest and there's not a client around to hear it, does it make a sound?
It depends on if you're running any sort of analytics tools. I have to be but no, I mean, it's going to be fun. I'm telling you, I keep getting excited. I have my Wi-Fi 7 APs. I've got my Wi-Fi 7 phone. I've got some opportunities coming up in the next couple of weeks to get in the field and actually do some really neat testing. So I'm really looking forward to it. I feel like I'm hyping it up a lot, but I really don't think it's understating it to say it really is. It's a more exciting shift for Wi-Fi than I think we've had. And I think part of that is, and we'll get it again, I'm getting ahead of myself, but it's Wi-Fi, and you hit on it before. Wi-Fi has become a need more than a want for a lot of people. It's no longer nice to have, it's a need to have. And I'll get into that again in a couple slides, but that's really, I think, part of it, where 10, 15 years ago, a lot of people didn't always see the benefit of it or didn't really think the technology was going to get there. And now everything is going that way, where, I mean, we probably all remember, right? Like you used to buy a laptop that had either you had to buy with a PCMCIA slot and then buy the NIC card, or it came, with a built-in NIC. And now, like, you don't get many ports on a laptop. It's a power plug and that's about it. Maybe some USB-C. There's no wired network. You have to buy an adapter. It's all Wi-Fi. So it's gotten very ubiquitous. It's gotten very pervasive. And I think that's one of the reasons why we need to go into 6 gigahertz spectrum, and Wi-Fi 7 is helping us get there. But it's also, it's just so much more important. So I think it impacts more people. So I think it all just adds up to it's a very exciting time.
Yeah, agreed. One of my former leaders made the statement years ago that Wi-Fi is becoming like oxygen. People just can't live without it. And it's that important. If you ask most folks if they would rather be without the internet or, power, they would say, give me the internet. Like, I'll take that first. And even as a cable guy, right? When I was still working in the field, I would show up to the scene of the crash, and the power guy's there, the phone guy's there, and the cable guy's there. Like, we had to wait in line until all of the important utilities were restored first before we could go put the cable back up, because it was considered a luxury. But now Wi-Fi is so important to so many people. It just connects everything.
It really does.
So yeah, it's crazy to see how that's evolved, but that's why we're having this conversation today, is because it has become that important, and people really want to understand it and how it works and what the evolution of it looks like, particularly in the cable operator space.
Sure. So kind of to round out the requirements part of it, I touched a little bit on it before, but we'll call it out by line: application and intent. And it's the same with any other project or effort, right? If you don't know what the use is going to be, then it's really hard to deliver the right solution. And, maybe it's a whole bunch of streaming video, maybe you're putting Wi-Fi in a classroom, different requirements for different areas. I mean, if you're trying to put one AP in an auditorium that's going to fit 1,000 people, it's going to be a really bad deployment. But if they tell you, hey, I just need Wi-Fi in this room that happens to be the auditorium, and they leave out the fact that it's going to have 1,000 devices in there, it's going to be a bad thing. So you just kind of have to help them sometimes think through what might be possible, the where and the what. And ultimately, you get all of that, and it lets you put together a good design. And we'll touch on it a little bit. I'm going to steal a quote from somebody else in the Wi-Fi community who probably won't see this unless I send them a link, and I might. But and I'm going to butcher it too. The idea is, Wi-Fi, a lot of the corporate Wi-Fi or enterprise Wi-Fi systems rather have gotten really good with software helping to improve the deployments. A lot of different algorithms and bells and whistles and nerd knobs officially to help tweak things. But there's no amount of tuning in the software that can help make up for a bad design. And so good design is imperative. Talked about it before. You want to make sure you put the access points where they need to be. If you're dealing with, we'll talk about an industrial space, right? You've got a machine shop, you've got a paint shop, you've got a warehouse, you've got a back office. Well, do all of the areas need Wi-Fi? I did a warehouse design 10 years ago, and I was told, don't put any Wi-Fi in the industrial space. They don't need anything in the machine shop. I'm willing to bet now that a lot of those new machines are probably Wi-Fi enabled. They've probably got some sort of, maybe they phone home for maintenance or updates or something, whereas maybe 10 years ago they didn't. Warehouse, sure, they use it for inventory and picking things and back office, of course, but maybe they don't need it in the paint shop. So you don't waste the money and the effort to put it in the paint shop. So just make sure you know where they do need it and where they don't. Again, garbage in and garbage out. If you get bad information in, it's not your fault, but it's going to lead to a bad design. Some key design elements, and this goes into if you're ever actually using a Wi-Fi design tool, scale is important, right? And it goes to if you're putting in a cable run, it's the same idea. You can't guess and say, I need about 10 feet, and then you're 2 feet short. You need to know the exact numbers. That's why when I travel into the field, I always carry a nice laser measure. I need to know how far the walls are apart. I need to know how tall the ceilings are so that when I do my surveys and I model, it's because it takes into account the algorithm and the tools, takes into account things like free space path laws and all the different elements of Wi-Fi to say, this is where the AP should be. This is where the AP should not be. This is what expected coverage would be. So scale is important. Attenuation values. What's your building material made of? Are we dealing with drywall? Are we dealing with bookshelves full of metal parts? Are we dealing with crazy titanium lined glass that blocks the solar, but also doesn't allow RF to get through it? Because if you have that, and I've dealt with that before, that AP that's right near the window isn't going to get Wi-Fi out to the porch. There's going to be no Wi-Fi out on the porch. So things like that, you need to know what you're dealing with. If you've got different attenuation zones, again, warehouses are good for these. Sometimes the shelves are always going to have, let's call it, transformers or batteries or something like that on it. Sometimes it's going to change by the week. And some of those are really hard to predict. And sometimes you have to just plan on getting Wi-Fi in one particular area, and the rest is sort of a best effort. Planning software, again, if you're using this, and I'm not sure how many people will actually get hands on some of the tools out there, but you need to make sure you've got that set right. There are different settings, same as any other tools that we're going to use in the field. Make sure you know your tools and you know how to use your tools so that you're using them the right way. You don't want to do, same as you don't want to do a cable crimp the wrong way, and I'm sure we've all done it, or maybe it's just me. Make sure you know what you're doing before you start going crazy, because you can do it wrong. And then ultimately, there is more to the software than a coverage map. I mean, the software that we get to use and I get to use, it doesn't just help me tell where to put the APs. If I walk the surveys, it's going to give me spectrum information. It's going to gather all of the various Wi-Fi interferers, not just my own Bluetooth, things like that. So there's a lot of tools out there that can cost a good bit of money. And we'll talk about some in a little bit that are much more affordable. That'll give you a good bit of insight, because at the end of the day, we can't see the Wi-Fi.
Yeah. And the interferers is something that I do want to try and get to today, because
sure,
again, to the point that you can't see it, there are, as the FCC describes them, unintentional radiators, and you may not know they exist. It could be anything from, electric motors to light ballast to who knows what, the microwave, vacuum cleaners. I've seen some crazy stuff.
Sure.
Emit, interference at a bunch of different frequencies. And, since it's all over the air, you can't really see it, but you can sometimes see the impacts or the side effects of it without having the tacit confirmation that, hey, this is where my unintentional radiator is coming from. Yep. So that's one that we could spend a lot of time talking about.
Yeah, I mean, back in the day, before I actually got into doing Wi-Fi and just thought I knew Wi-Fi, back when I still thought using the stuff off the big box store shelves was, and just one of them in a 3-story house was sufficient. I had bad Wi-Fi in certain spots in my house, and then I came to learn Wi-Fi more and realized that, like, I had bad Wi-Fi in the kitchen where I used to hang out at night because I'm right by the refrigerator, which has a nice electric motor. My wife was on a call once, or she was streaming something actually, and I put something in the microwave, and all of a sudden, Netflix is spinning. And she's like, what's going on? Is something wrong? I'm like, hold on, let me turn on the microwave. And she didn't believe me when I told her that it would do it, but turn off the microwave. Sure enough, yeah, everything worked fine. It's one of those where, and there's a lot of other things too, right? So some of those streaming devices have remote controls, and they operate their own private wireless network. Instead of using Bluetooth or IR, they use cheap Wi-Fi. Perfectly fine, but it adds a source of interference. Some of your kids' game controllers or your own game controllers can also generate some interference. Most of this interference, not all, but most of this is predominantly seen on the 2.4 spectrum as opposed to the 5. There's more space on 5, which we'll see in a minute. But a lot of it seems to be more problematic on 2.4. Microwaves, for example, are only 2.4. Yeah, Bluetooth. So it's Bluetooth will be there, and microwaves will definitely be causing problems on 2.4. Bluetooth, I have some funny stories on Bluetooth and 2.4. We can get into that if we have time. Proper installation is worth calling out when we're talking about baseline foundation of Wi-Fi, because it's one thing for me to design it and say, I want good Wi-Fi here. But then it's another thing to make sure that the people I've tasked with installing it actually put it where it's supposed to go. And I say this because, first of all, every AP that you could get has an installation guide. Good example, Ruckus, we sell H series, R series, and T series. I don't expect any of you to know this. There won't be a test at the end of this. But our H series are wall mount APs that you will commonly see in like a hotel setting. If you're ever traveling and you look around your desk or behind your TV, you might see a Ruckus AP. Little flat rectangular box. Very common in a lot of our hospitality spaces. The R series are ceiling mounted APs, and the T series are our outdoor APs. But I mentioned that there are installation guides for each of them because most of our T series APs are mounted similar to our R series, which is like straight down from the ceiling, pointing typically 90 degrees at the floor. The H series are all intended to be mounted on the wall, but some of our T series are designed to be mounted on the wall as well because they've got a different antenna orientation. So the design guides are important for that. But it's also important to make sure that they install them where they were supposed to. I've had plenty of designs where I called out an AP to be put on the map in one spot, and the installer made a judgment call to move it 5 or 10 feet the other way, which can sort of goof up my coverage plan. Now, in some cases, they didn't have enough on the run, and they made a call because they didn't want to run a whole new spool. In some cases, they made a decision because there was ductwork that wasn't called out on the map, and they couldn't get it to where I wanted it, so they had to get it as close as possible. But it's important to verify it, and for that, usually somebody just eyeballs it. In a small business setting, they're probably a little bit less challenging to deal with because you're probably only putting 1 or 2 out there. And it's sort of, it's obvious where they're going to go. You're going to put it where it's nearest to the customers and those mostly using it. And one thing I like to call out, I love to call out proper documentation, because at the end of the day, I might do this design, but I might not be here in a year. Something might happen. I might move on. Whatever the case may be, I don't want to leave the design undocumented so that people don't know what I did and why. So that's important. And then for me, and this is what I was actually doing a couple of weeks ago, is it's important to go back and validate with tools, with measurements, even just testing with a device, a laptop, a tablet, or whatnot, that the deployment went as planned and actually is delivering the service we expected to deliver to the customer.
The way I'm hearing this,
go ahead.
The way I'm hearing this, John, is it's a little more front loaded when you're doing a Wi-Fi installation. Talking about the tooling and different things. So like in a wired configuration, you do your survey, you run the wire, and then at the end of it, you can measure, what your signal levels are at that point based on the length of the coax or fiber or whatever. With Wi-Fi, there's so much in there that you mentioned just about like Wi-Fi or the antenna orientation and polarity, whether it's vertically mounted or horizontally mounted. The radiation patterns of the lobes of the antennas themselves, right, create a space with different signal strengths. And it's so important to like front load that and understand your equipment in the area that you're trying to serve. Because at the end of it, you can't just like walk to the other end of the room and plug a meter into it and say, hey, the signal's good here, right? It feels a little bit more front loaded of understanding your equipment, understanding your antenna design and the construction or the space that you're trying to install rather than just running a wire and calling it good.
I mean, that's a fair assessment. And I look at it as, there's still plenty to do post install from the configuration and all that, and we're not even going to get under the hood there. But I'll tell you, this is coming from 10 years of experience where I've seen plenty of deployments that I've inherited and had to fix, where a lot of these basic steps were not either they didn't know to do them, they didn't have the tools to do them, or they didn't care to do them, or a combination of the three. And Wi-Fi as an effort has matured a great deal, because again, to your point, what we keep hammering home, it used to be a nice to have, and now it's a need. It used to be one of those things where you would call up a ticket at work and say, I need Wi-Fi or I want Wi-Fi, and they would just kind of throw up an access point right by your desk so you had it. And now it's not about like, well, we're going to give Wi-Fi to Michael or John. It's we need to cover the entire floor. And 6, 8, 10 years ago when I was starting, it was we need to cover the whole floor, but they still have wired connections. And now it's, what do you mean we need a wired drop? The whole floor, the whole office is wireless. So it's becoming more important, and it's important, same as building a house, which I've never done, or, fixing a car, which I've never done. You need to make sure you start right with a good plan, and there's still going to be work to be done at the end. But if you get good information, you follow everything, and you follow the process, it should set your Wi-Fi deployment up to be very good from the get-go, and then just kind of tune it and adjust to what your users are doing. And again, it's sort of a nebulous statement. I'm talking from experience of supporting some large global enterprise type deployments, but the same rules on a smaller scale hold true, even if it's a small store, a small office, a school, small school. Big schools are the same idea as a big company in my experience, but it's important. At the end of the day, if you prepare and you follow through those steps, it'll set you up well for success down the road. Post install is a little bit harder to do without those tools because some of those are designed exactly for that. But that is walking in and making sure it's installed. And a point should be near and dear to your heart, and we'll get into this one. Cabling matters, and it actually matters more now than perhaps ever. That's probably a little bit hyperbolic, but it's going to matter more now as we move to Wi-Fi 7, because you're going from Cat 5 to Cat 6, and the power, the draw that the cables are going to see is going up. So you need to make sure you've got cabling that's properly rated for it and can handle it. PoE is going to be very important when we get into Wi-Fi 7 APs, because you're now dealing with a third radio, so they're going to be drawing more power. So, and we'll get into that in a minute.
There's a lot of parallels in that one too to coax and wireline networks, right? It all starts with a good design, knowing how much signal you're trying to deliver to the end point, having the right cable size for the frequencies and the distance and the power consumption, all that. There's actually a lot of parallels. Just one of them you can see, the other one you can't.
Yes. And I actually had this conversation with a group of Wi-Fi engineers. I've had this a few times this year. Because this is honestly, as part of an installation process for larger deployments, cabling is part of the physical plant that I think gets overlooked a little bit. But the reality is, even so, we've got access points that Ruckus has made, and I'm sure some of our competitors have them as well, that can actually be connected to a 10 gigabit network drop. We've got switchgear that can handle it. We got APs that can handle it. And that's great to handle, large dense deployments. But if your infrastructure, I can't talk today, if your infrastructure is not Cat 6A, you won't get the 100 meter that you're typically expecting out of an Ethernet run. It won't work on 10 gig. It'll only get you about 37 meters. So 6A and above is basically kind of the baseline if you want to make sure you're going to be able to throw that 10 gig out to 100 meters, or about 330 feet, if I remember correctly. So it's important. And ultimately, the part of that is make sure it's properly rated. I've heard some people, maybe some of it's FUD, but I've heard people, wouldn't necessarily say it's probably FUD, but if you've got the improperly rated cable and you're putting it in the wall and then you start pulling like 40, 50 watts per AP times 10 or 15 APs and they're all in a bundle, that's going to get hot. And that could be a hazard.
Yeah.
So it's gonna be interesting, but it's worth mentioning again as you go out to the field, whether it's a single AP pull or multiple AP pulls. Anything over 37 meters, and it's got to really be Cat 6A to make sure you're going to get 10 gig. And you want to do that because, Cat 5e was a thing. How many years ago at this point? It's had a nice run. It really has had a nice run. I remember learning. I'm pretty sure some of the first cables I started crimping were Cat 5e. And I was told how expensive it was at the time. But it's been in the walls for a couple decades now. So odds are if you put Cat 6A or Cat 7, depending on the cost and all that, I know that it gets thicker and it's a little bit, as we move down to Cat 7 and Cat and beyond, it's getting thicker. It's getting a little bit harder. It's getting a little bit bigger to maneuver in the raceways and whatnot. But chances are you're not going to pull it again for a long time.
A while.
It's going to get you. I don't want to put anything out there and say, well, John said it's going to last me 20 years. I have no idea. But the reality is we still have today, it's important to mention Wi-Fi, and I'm jumping the gun here. Wi-Fi is 25 years old this year. We still have devices out there that are basically OG first generation Wi-Fi prime type stuff that can work on Wi-Fi now if you support 2.4, just because that's how Wi-Fi is. And again, you mentioned DOCSIS being backwards compatible as well. So it might not work awesome, but there's a very good chance you install Cat 6A today in 25 years. If nobody's pulled it out and upgraded it, it'll still work in 25 years. It won't be up to the latest standards probably, but it'll still work. So, you'll get a nice long run out of that. And again, power. Now, again, I mentioned before, I will only speak to the Ruckus gear because it's what I run and sell. But this is more of an example of the power draw that these access points, when you're dealing with an enterprise AP, are going to look for when you're introducing a third radio for Wi-Fi 7. The number of devices supported, you can kind of glance over that. That's talking about our particular switch models. These are compact switches, which I like to run in my home lab. But each one of those APs, the 560 is a 6E, and the 760 is a 6E, and the R770 is our Wi-Fi 7 AP. They're all tri-radio. They're all going to ask for 45 watts, which is a lot. So, if you're doing a larger deployment, if you're doing, maybe it's one of those medical surgical units where they've got a floor and you're putting in a switch and multiple APs, you've got to make sure that switch is actually going to be able to power enough devices. Because if it can't, it either won't come up at all or it won't come up with the full functionality. And then you've got a customer calling you going, I paid you for a Wi-Fi 7 install, but I'm getting Wi-Fi 5 speeds. And the reason for that is, there's no power or not enough power. So the APs are coming up in like a limp mode where not all the radios are coming up at full power. So it's important. It's another factor to consider that, I had some people in conversation which were like, you can see the budget that they had planned for an upgrade just went up by a factor of however many, because now they've got to upgrade the switches as well. So it is something we have to consider.
Yeah, a lot of parallels here too, because most of the coaxial networks are active networks and do require power, and so we're pretty familiar with Ohm's law and the impact of some of the newer amplifiers and nodes and their power consumption. because the resistance is relatively fixed in the impedance in the network. So, Ohm's law is pretty straightforward. Resistance being equal, if you consume more power, you're going to have more current draw.
Yeah, and it's sort of, but for whatever reason, it's something that gets overlooked a little bit. I think, hopefully not as much. And I'm doing my best to make sure nobody that works with me is overlooking it. But it's, and it's crazy. And I like to say this, laugh, because everybody says wireless is easy because there's no wires involved. But you can't have wireless without a wired infrastructure. So it really is important to get, a good backhaul to the ISP and, good switch infrastructure and the cable plan as well. So it all adds up. And that's kind of a big part of it. And then we could segue into tools and troubleshooting, which, we could spend hours just talking about that. But there are, and I've talked about, or I've alluded to it, there are a number of different tools that we get to play with as Wi-Fi professionals. And some of them can be really expensive and some of them can be really simple. And so I put this together because not everybody is going to go out there and buy, and I won't name names because I'm not going to plug anybody in particular. Well, I might as well name a couple at least. There's some common names. Fluke used to own some of them. I know they still do some testing devices, but they spun out. NetScout now does, or NetAlly, I think. NetScout, NetAlly. There's some nice handheld testers to help find the APs when you can't find them because it's buried underneath the drop ceiling or behind drywall. There are a couple different tools that are also have some spectrum analysis capabilities. Ekahau has one. It's been the standard for the most part for the last, basically for my career. You'll hear the Sidekick talked about often enough, and chances are, if you do enough of this, you'll see a Wi-Fi heat map probably done in Ekahau. I don't think I have any in my presentation, but the problem with some of those tools is for the average installer, the average tech that's in the field, if this is just part of your job but not the job you do, some of those tools can have a steeper price point. They're not things that you're going to go out on your own and just invest in. It's not like you're going to, the hardware store and you're going to pick up a $10 hammer or whatever. It's not something like that. Some of these tools are thousands of dollars and require software subscriptions and whatnot, and in some cases training as well. But you don't necessarily need tools, right? You've got your cell phone. So there are ways with Android and Apple devices where you can get a decent idea of signal strength just from looking at your phone. I believe they've built it into the Mac OS now as well, where you can kind of just look at the Wi-Fi and drill in to see what my signal strength is. You'll know your SNR and things like that. It requires you to have the laptop, but chances are you're probably doing a deployment with a laptop anyways. If you have a laptop, there are tools. I'm a big fan of one called Wi-Fi Explorer Pro, which is on version 2 now, which is a company called Intuit Bits, a gentleman by the name of Adrian Granados. I'm going to show a screenshot of his tool in a little bit here. But it started to run on Mac. It also now runs on Windows, I believe, or will. I'm not a Windows person, so I can't speak to that. But it uses your Wi-Fi adapter in your laptop and shows you your spectrum. It'll show you what's around you. It'll show you signal strength. It'll show you your neighbors, so you'll be able to see if you've got any interference. If you're remote, and this happens to me a lot, maybe not so much for field techs, but I've had time in the past where I've had to support customers remotely, sites remotely, and they do make, Raspberry Pis are a wonderful tool. There's a lot of other small single board computers that are, I don't want to call them cheap, but they're relatively inexpensive, a couple $100 for a nice kit. And you can configure one of them with open source software to basically function as a Wi-Fi probe of sorts, send it out to the site, plug it in, and it'll phone home and tell you how the site's behaving. So there's a lot of different ways to get a lot of information out there, and not everything requires an arm and a leg or a heavy investment from you or from your company. So that's a nice thing. There are some free tools, I believe. I don't know if he still does it, but Wi-Fi Explorer used to have a light tool, which gave you some of the functionality. And again, I talked about it before. If there is budget and there is an option for it, the design tools are invaluable. But again, not everybody can have the tools. Not everybody has the budget. You go out to the site, you have your cell phone, you got to be able to call up a buddy, stream your music from your streaming device of choice and walk around the room and figure out, like, am I starting to buffer in a certain spot? Do I lose coverage? Do I have no signal here? It's not the most scientific way to do it, but it is something that you'll have on you no matter what, probably. And ultimately, depending on the deployment of APs, some vendors, some platforms are building in some additional advanced capabilities into the APs themselves that will allow you to get some really neat, interesting metrics to help you troubleshoot problems. You could do speed test. I'm not a huge fan of speed test, to be honest, or at least not in the way that a lot of my customers tend to use it, because the argument from me is that speed test, whether you go to Ookla or speedtest.net, or, I think there's a couple other ones out there, you're testing the backbone, really. You're testing from your core router to the internet. So you could get a really poor speed test and it might not necessarily be indicative of a Wi-Fi problem. It's entirely possible that you could do a wireless speed test and it's actually indicative of a core network problem. But because you're doing it from a wireless device, people jump to conclusions and say Wi-Fi is slow. And one of the things I did in a corporate environment, which I know is not practical for everybody, but there is, and I cannot remember the name of the tool. I'm drawing a blank right now, but there is actually a way to effectively do like a speed test server on like a Linux box or laptop or VM, if you will, and you just build it up, you give it an IP address. We did this in a corporate setting because we had customers that love to use speed test as the go-to end-all be-all. And we had one time where we knew it was a wired network issue and they didn't believe us. So we built the internal server, and instead of hitting, a public IP address, we were hitting an internal corporate IP address that was the IP address of our server. At that point, it was testing how good we were from the Wi-Fi to that box before we even got to the edge router. And we were able to show like a 2-fold, 3-fold increase in the speed test. At which point they said, well, yeah, maybe we do have a wired problem. So that's a long-winded way of saying, like, it's not a bad tool if it's the only tool in your toolkit, but be careful putting too much stock in it, because if you have the ability to do a wired speed test as well, do that to validate it. Because if you're not getting any faster on the wired, then either maybe you're at the max speed of the link, or that's link is misconfigured or something like that. I don't put a lot of stock in speed test just because of that. I do use it from time to time, but I try to make sure it's sort of a trust but verify.
Yeah, tools are so important, man. No matter what the technology, because the old saying, when the only tool you have is a hammer, every problem looks like a nail.
Exactly.
And if that's the only one you have, you can spend a lot of time troubleshooting absolutely nothing, and not find anything. So,
yeah, I will say this with Wi-Fi, and I know we talked about this a little bit before. Some of the tools are really expensive, and you can get into, and I think Fluke still makes some of their meters, and I think they're probably have fiber testers and things like that. I know I've seen some of the bills on the Fluke stuff, even the non-Wi-Fi tools, that get really, really crazy pricey. So obviously there are certain tools that just can't be had by most. I've done Wi-Fi on a real shoestring budget, and you find a way to make it work. And it's definitely one of those things. And I think the same is true with anything, right? If you get a cheap hammer and a cheap set of screwdrivers, it'll work. And then when you're finally able to sink a little bit more money into that really nice set that's like precision crafted and better material, and all of a sudden you realize that, like, oh my God, it actually does, like, it doesn't strip the screws out as much. It doesn't, I can screw them on much more easily. It ratchets. I'm not working as hard. Because when you have a tight budget, you realize, like, I can't afford that. I don't need that. You talk yourself out of it. But once you get the right tools for the job and you can actually swing them, it's not hard to justify them when everything makes sense. But, thinking in terms of some field staff that you're not doing Wi-Fi as a core focus, like maybe somebody like me is, there are definitely tools. I mentioned Wi-Fi Explorer Pro. It's not cheap. But compared to some of the other tools, it's very, I would consider reasonable. I haven't bought it recently, but I feel like it's about a $200 investment, which in the grand scheme of things is not a big deal. I don't think, or not as big of a deal when I'm talking about some of these tools have an annual subscription of, for maintenance and support for,
thousands of dollars.
Exactly. Yeah. So it's one of those things where, and it runs on your laptop. You can use it at home too. It's great. He has one. I can't show it because I'm not sharing my whole desktop, but there's another one called Wi-Fi Signal. I love it. I'll tell you the story and then we can talk about Wi-Fi 6E. I was in an office one time. It's literally 2 a.m. I was the only one in that section of the office. My laptop was on the desk. I wasn't moving. Dead quiet office. I would literally, there were other people in there, but I was the only one in that part of the building. So there was no reason, there was no traffic. There's no reason for me to be doing anything. Wi-Fi Signal sits in my toolbar at the top of my Mac. I believe it is Mac only. And you can set the flags for what it tells you. And like I'm looking at it now, it'll tell you the SSID you're on. It'll tell you what band. It'll tell you your signal strength. It'll tell you like MCS rate. Based on all of your conditions, like the max throughput, you should be able to see if you're roaming or not. Like it'll actually change and say you roam to a different channel. It'll actually pop up on your screen and say you just roamed from this device to that device. And I'm sitting there, I'm not moving at all. And all of a sudden it just pops and says, you just roamed from 5 gigahertz to 2.4. And I mentioned this for 2 reasons. One, the tool is great because I wouldn't have known I roamed unless it popped up. You don't see it on a laptop unless you just happen to notice that your Wi-Fi dropped. And by the time you noticed it dropped, it came back. But it also, I mention it because it's another example. And granted, this was 6 years ago. So the clients are much better now. But it's another example of clients making that decision. There was no reason for me to be roaming at all. But for whatever reason, based on the information it was gathering from its wireless adapter, my laptop said, guys, we're going to move to 2.4. No reason to do it, but the client just decided to do it. And there was nothing I could do other than shutting off 2.4. But that's a good tool. And that is, I think it's, unless he raised the price a little bit, it's call it under $10, or at least it used to be. And it's not nearly as powerful as what we'll look at in a little bit, but it's still very valuable. And I love Adrian's tools. I'm not on his payroll at all. I think he's like a mom and pop independent developer kind of guy. Huge friend of the Wi-Fi community. So I love plugging his stuff. It works and he listens to the feedback really well. And he does have like support for Wi-Fi 7 out there already. And he's getting the packet captures and helping filter them out and all that. So strongly recommend him. If you can't get any other tools but that, you could do far, far worse than having that on your laptop when you're going out in the field.
Yeah, before we move on to Wi-Fi 6, like we're real big into craftsmanship, right? Because there is a lot of craft sensitivity when you're talking about technology and constructing networks, whether it's optical networks, coaxial networks, twisted pair, whatever. And I was fortunate enough to grow up with father and a father-in-law that were craftsmen in different industries. That taught me a craftsman is only as good as his tools. You mentioned the cheap hammer and screwdriver. Yeah, in the beginning, it'll get the job done. But if you're serious about being good at your craft, whatever that is, like there are tools that will allow you to be better craftsmen. So I've learned that as an adult, and I could afford to buy better tools. They make you a better craftsman.
100% agreed. Like I see it all the time with everything. It's like, wow, I can't believe, like, you sit there and you debate the purchase, and you buy it, and you're like, how did I live without this? And it's true with the Wi-Fi tools. But again, I'm not trying to encourage anybody to go buy super expensive tools because sometimes you don't need them.
That's exactly right. So let's talk about that for a second, because, I got super excited as a cable nerd, right? I was able to buy a Rodian Schwartz handheld spectrum analyzer, an FSH, super awesome piece of equipment, right, to go do over-the-air interference troubleshooting and hunting. And that instrument, I think, was a reasonable $15,000 or whatever. For a Rodian Schwartz, that's pretty cheap. And then I bought this guy for like $150, which is a tiny SA Ultra. And I can do a lot of the same things with this for $120 that I can do with my $15,000 instrument. So it doesn't always have to be expensive to be good. And one of my dogs is making an appearance on the show, John.
Nice. Well, we don't mind dogs here, so.
Not at all.
But no, I mean, and it's one of those things. You made a good point too. Like, for whatever reason, and we won't get into the geopolitical and geoeconomic ramifications of things, but there are really good tools now that are a lot cheaper than they were back when they first came out. I mean, and ultimately, if you find something that you're comfortable with, that you could afford, that maybe cost you a couple bucks, but it does enough that you know that the Wi-Fi is good, or the deployment, whatever it is, doesn't have to be Wi-Fi, is good, and you're satisfied and the customer's happy, then call it a win and you're off to the races. I mean, there are tools out there that I could spend $20,000 on, and they're awesome tools. But if you don't know how to use it, or you're not comfortable using it, they're not, I mean, the $20,000 tool is not going to make you a better deployment person. They're not going to make you a better installer. It's the training and the experience to know how to use the tool, as well as the tool. That's why I'm saying, like, you could spend $200 on certain software and get familiar with it and be a rock star. Yeah. Or you could spend $3,000 and the subscription costs and look like you know what you're doing, but still struggle because you never bothered to figure out, go to the class, whatever, and understand how it works. So, yeah, knowledge is power as much as anything else with this. And yep. So with that,
Wi-Fi 6,
I think it's a good time to talk about. So we're going to talk about Wi-Fi 6E and 6 gigahertz, and eventually we're going to segue into Wi-Fi 7. But first, we have to start with a little bit of a history lesson. So I mentioned a little bit ago, this is the 25th birthday of Wi-Fi, 25th anniversary, call it whatever you will. So 25 years ago, 2.4 gigahertz was all we needed. It reigned supreme. It was a nice to have. You only had 3 non-overlapping channels. It's important for me to stress this. You'll hear people say, well, Wi-Fi 2.4 has 11 channels or 13, depending on the part of the world you're in. Yes, but you want non-overlapping channels in every spectrum because you're not interfering. So there's only 3 clean channels in 2.4. You had speeds from 11 megabits per second to 50 more, up to 54 megabits per second, which honestly is not bad, although we're capable of doing much, much better than that now. And it was a nice to have. You did not need to have it. I mentioned before, people would call and they would just get one thrown in their office if they could get it, or, you know, I remember deploying the first one at my house when I was still living with my mom when I was in my 20s. And like, I didn't even give her the password. I don't think she had any devices that could use it. It was a nice to have. Nobody else needed it. Didn't matter. I didn't really have that much that used it. It was just a nice to have. But now it's a need to have, right? And we get to Wi-Fi 5, or 5 gigahertz rather, and we get more channels. I talked about the 3 non-overlapping. We can get faster speeds. We have more channels, right? It's more of a need than a want. But because it became more of a need than a want, we made a mess with Wi-Fi. And so this is actually a screenshot from Adrian's tool. And a buddy of mine sent me this from one of his labs, and I actually sent him one that I did from a field test, and it was even worse. But this is an example of 2.4 and 5 gigahertz. Actually, no, I'm sorry, this is only 5 gigahertz. I had to duck around my camera there for a minute. So this is only the 5 gigahertz spectrum. So you're looking at channels for the entire spread of the spectrum, and you can see it's just a mess, right? We have, and you can see there's DirecTV, there's Roku, there's, a whole bunch of, just different endpoints, testing, different ISPs. And what you see here is all these different lines is a mess of, you've got 20, 40, and 80 megahertz wide channels deployed in this space, and they're overlapping and they're interfering, and it's an ugly, ugly mess. And you've got a couple channels there in the middle. Nobody's on 120 and 124 and 128. It's kind of hanging out 144. Some of the channels get avoided for one reason or another, but it's a mess. 552 wireless networks from just this one scan. And this is why we need more. There's a joke with Wi-Fi professionals. Years ago, people said 2.4 is dead. And as we talked about before, 2.4 is not dead. It's not going anywhere. And if anything, actually, Wi-Fi 7 is going to make it become a little bit more relevant again. But we can never have enough spectrum. So we need more, which means it's time for 6.
Yeah, interestingly, so like we're talking about the over-the-air spectrum and the data rates, between the client and the AP. But the core network that's connected to has expanded too. Going back 25 years ago, the network that was connected to that AP wasn't as robust or didn't have the bandwidth or the modulation profiles or anything, to support anything much more than 54 megabits per second. Like we thought we were doing great at like 23 with DOCSIS 1, when that first came out, regardless of what the AP could do. So, it's both the core backbone has improved along with, the bandwidth and throughput accessible on the backside of the AP. So now it's about getting the client and the AP data rates to, satisfy the capacity that's available on the network that it's connected to.
Yep. I mean, we're growing in leaps and bounds across the board. And I mean, I think, a lot of us can remember when we used to get on the internet at home with dial-up. We were used to hearing the modem screech, and that was, we could complain it was slow, but show of hands, how many people have downloaded music or files right before you went to bed, hoping you were going to wake up and it was going to be complete.
It's going to be done. Yeah.
And not be interrupted and have to redo it. And now my kids can't appreciate that because it's grown where it's just, it's ever present. It's just a part of the fabric of life at this point, which kind of scared to say it a little bit, but
it is, but it's instant gratification, right? We're so used to being connected to this super wide information pipe and being able to access whatever we want, whether it's music or video or files or work or video. Like people are just so connected to it. It's become part of the fabric of our life, as you mentioned. And the expectation is that it's going to continue to be there. And oh, by the way, there's technical use cases that haven't even been developed yet to fill this pipe that we're still building.
Oh yeah. And that's one of the areas where Wi-Fi 6 gigahertz gets really, really crazy. Excuse me. I don't think I have a slide on that, but I can talk to it real quick. A lot of the early adopter kind of technologies that they pitched for 6 gigahertz were things like AR and VR, like the reality headsets and things like that. So that they could have like a battery pack and the headset, but they weren't like tethered to the computer because they would have enough processing power and the throughput, the bandwidth with a 6 gigahertz pipe on a small local link of, you're within whatever distance to the main device or whatever. And I'm not a VR guy and it shows, but they were thinking, 6 gigahertz would be perfectly fine for it. And it may be because it does have a lot more capacity, but it's wide open. It's a brave new world, and it's a lot of stuff to get excited about. I've said it a couple times. Now I guess it's really time to show everybody. So to level set, so there's 6 gigahertz, and then you'll hear Wi-Fi 6E and Wi-Fi 7. So Wi-Fi 6E is basically known, call it 6E, it was Wi-Fi 6 extended. 6E gave us the 6 gigahertz spectrum. That's when it became available to Wi-Fi. But that's about all it gave us. That's not all it gave us. So I don't want anybody going and sitting there, John got it wrong. It gave us other stuff too. But mostly it was known for giving us the 6 gigahertz spectrum. And that's part of the reason why I think a lot of people skipped or waited until Wi-Fi 7, because Wi-Fi 7 gave us the 6 gigahertz spectrum with a whole lot of stuff to do it. So 6E gave us 1200 megahertz of spectrum, which is a lot, but adoption was slower. We talked about it. Part of it was, I think developers and vendors all saw that Wi-Fi 7 was right around the corner, and in part with the global pandemic where nobody was buying things because nobody was in the office, it was a slower adoption.
But they were consuming bandwidth, as the operators will attest.
They were definitely consuming. So 6 gigahertz, not 6E, but 6 gigahertz gives us 59 channels. It's more than double the 5 gigahertz spectrum. And think about it, 2.4 has 3 non-overlapping channels. Okay, we've come a long way. And to visualize it, so this is all of the available spectrum, looking at 6, looking at 5, and looking at 2.4. And there are some caveats. For example, the 5 gigahertz calls out the DFS channels, which we won't get into now. But you can see how much we've grown. And to go back to that visual aid of the 552 networks from the Wi-Fi Explorer Pro screenshot, you can see why in the 5 gigahertz band, some of those networks cause a lot of disruption. You can only have 6 80 megahertz wide channels in 5 gigahertz, and those 80 megahertz wide channels coexist with the 40s and the 20s, but they overlap. So if you've got an 80 on your neighbor's device and you're running a 40 and your other neighbor's running 20s, well, you're all kind of stepping on top of each other if you're in the right part of the channel plan. So it gets to be messy really, really fast. With 59 channels max, if we run 20 megahertz wide and 6 gigahertz, in theory, we should be able to keep our neighborhoods a little bit cleaner, a little bit longer. In talking with professionals, peers, if you will, the jury is still out where we're going to settle on a recommended sort of best practice channel width. A lot of people for the 5 gigahertz have tended to settle on the 40s. 40 is probably not a bad spot to settle on in the 6 gigahertz as well. You're going to get plenty of throughput, plenty of performance, and you'll still have 29 usable non-overlapping channels. So, but again, I stressed before, Wi-Fi 7 is really in its infancy. So there's going to be a lot of learning that we're going to be doing over the next months and years to come. Even though Wi-Fi 8 is already well being thought about and planned, Wi-Fi 7 is really just beginning to give us what it has to offer.
Are we getting to the point, John, where AI can help us to like organize and arrange that spectrum at the client level so that there's less overlap, sort of some automated spectrum management at the client device?
So not necessarily at the client device level. It's one of those where it's the funny marriage of Wi-Fi is so the client devices, again, whether you've got Apple or Android or Google or any of them, they're going to make their own devices. They're going to make their own algorithms that are going to tell their wireless devices how to perform. It's one of the things wireless professionals used to love Android devices, or at least make sure they had one, because Android was a little bit more open and you could actually have some sort of open source tools on an Android phone that would give you some really like open source, low budget, not spec-and, but like some Wi-Fi scanning tools. They've all closed those things off because they prefer to favor the battery management and they want to make sure their devices have longer uptimes as opposed to open source. So I think ultimately the clients are still going to make their own decisions, but what you're seeing with AI, so I can speak from Ruckus in particular, we do have a tool called Ruckus AI, which is an analytics platform that will ingest all sorts of metrics out of our controllers. And we do have a channel management portion of that called AIRRM, which will basically do a digital twin model of your wireless network and say, based on what your devices are, your APs are doing, what the spectrum looks like in your area, wherever they're deployed. Okay, it's currently deployed with this channel plan, and we've literally modeled it up with all of the permutations of any other channel plan we could come up with. And based on the digital twin we formed, this is the model with the least amount of channel interference or channel interference, any sort of contention, anything at all. And the idea is to reduce or completely eliminate the interfering links. So there are things like that. Ultimately, otherwise, just speaking at a high level without getting into vendor specifics, there's a lot of tuning in the software that allows us as wireless engineers to, from an enterprise level, and even some of the like the cloud offerings and whatnot. There's things like band steering. We can design the network to sort of influence the devices to want to favor a particular band more than others. The old adage was you make the 2.4 like half as powerful as the 5 gigahertz radios, so that it always presents as a 5 gigahertz radio as a more preferred connection. And there are other ways, and I'm sure other vendors have even more creative ways to do it. But there are ways to do it. Ultimately, going back to my stories from a minute ago, client devices, client decisions, while still sometimes a sort of a punchline, they've gotten significantly better than they were 3, 4, 5 years ago, where they're not necessarily making the same crazy decisions where it's going to roam randomly to 2.4 just because. But at the same point in time, if you're running a network where they are desperate to have a 5 gigahertz connection, the only way to ensure that they won't join 2.4 is to turn off the 2.4 radio or have the client on an SSID that is 5 gigahertz only. So there are a couple different ways to do it. more time would be necessary to jump into that particular rabbit hole, but there's a lot of things coming, and I think AI and ML are really going to start playing more of a part in the Wi-Fi world. And the reason especially is on the screen right now. Just looking at the Wi-Fi 7, the 6 gigahertz spectrum rather, channel plan. There's 59 channels, 1200 megahertz of new spectrum that we have to deal with, that we want to slice and dice and maximize. And AI and ML hopefully are going to help us really do that. And that's where a lot of things are going.
Yeah, and signal strength is going to have a lot to do with this too, right? Because the higher you get in frequency, the greater the attenuation, even in free space path loss. So the clarity of the signal and the direct line of sight to the AP and obstructions are going to be really important to effectively maximize the higher frequency spectrum.
Oh, 100%. And you, I'm not sure if you were looking ahead and just made a nice segue or not, but I'll give you credit for it. Power is a big deal. You always want to get your AP, and we kind of mentioned a little bit, you want to make sure your clients and your AP are as close as possible, not as close as possible, but make it as close to them as you can possibly get it. I mean, you don't want them sitting on it because it's an AP, but you don't want them connecting to an AP that's 50 feet away if you can put it like 10 feet away. Relative to power, we mentioned it a little bit with the 5 gigahertz. DFS channels have a different power limit on them. Wi-Fi 6 gigahertz has a similar component to it. If you look on this chart, you've got standard power and you've got LPI. Not every channel can do standard power. Not every, and so if you're looking at this chart, reading it left to right, so Uni 6 right in the middle can only do LPI. You'll only see this on an indoor AP. And then Uni 8 at the very end of the spectrum, again, will only be LPI. Whereas Uni 5 and Uni 7, these sort of salmon colored headers, they can do both. And there will be some power requirements, some different power spectral density that'll come up into play. And again, this is another rabbit hole. We could spend an hour talking about that. Unfortunately, we don't have the time to dive all the way into that rabbit hole, but trust me, that's a good one. But there's a lot more to be considered here. So that certain devices, certain APs can't function in, like, you can't put a standard power AP in Uni 6 or Uni 8, and you can't run a standard power AP without AFC, which is automated frequency coordination, requires connection to a clearinghouse. There's, I believe, 13 different providers of it. I will talk about that in a minute as well.
Well, I'm going to challenge you. We're going to go down the rabbit hole one of these days with power spectral density. And
I might have to call in a reinforcement because, and honestly, I believe we did a podcast about that where we did go down that rabbit hole a good bit. But it's RF math at the end of the day, and so it does make sense, but it's a different spin on it, and it's certainly worth a conversation. Part of me not argues, but this is when I say you almost have to relearn Wi-Fi. Because it is a different way of doing it. But so there are different rules. And again, there's with all of the PSD and the different requirements with what we've gotten out of Wi-Fi 7, there are rules about fixed antennas and things like that come into play that maybe didn't come into play as much with Wi-Fi 5 and Wi-Fi 6. So it's a new world. We're learning as we get into it, really, because again, it's easy to talk about it. It was easy to read about it, but now that we're actually getting hands on devices, I think a lot of good information and good material is going to be produced. And I have a feeling we're going to be back to talk about it. So I think AI and ML is definitely going to help with that, but it's a lot to take in. I mean, it's 59 new channels. I think there's enough safeguards in place that hopefully we don't make it as much of a mess, but we didn't think we were going to make 5 gigahertz a mess either. And we did. So more of everything, though. You got more speed, more capacity. There are, again, management and restrictions, which gets us to Wi-Fi 7, and that'll give us the restrictions. This is our latest generation. One second. So it is our latest generation of Wi-Fi. Again, this is 802.11be, also known as Wi-Fi 7. That's the marketing. It is the first Wi-Fi amendment that is specifically engineered to take advantage of 6 gigahertz. We've got LPI, which we talked about. There's standard power, which is tied to AFC, which we've also talked about. It is also referred to as extremely high throughput. So some are efficiency, some are throughput. This was throughput. The max theoretical, which you're never going to see in a home device, is 46.1 gigabits per second. We also get with it punctured transmission. You get multi-link operation and a whole lot more other stuff. It's literally, we're scratching the surface. I mentioned it a little bit before. AFC is required to run an AP in standard power. You cannot run an outdoor AP in Wi-Fi 7 if it doesn't talk standard power, if it doesn't talk to AFC. Can't be done. LPI specific AP cannot be used outside. There are rules against putting an indoor AP into an enclosure. But again, if you really wanted to put an outdoor AP or an AP outdoor, you're going to need the enclosure anyways. I suggest getting a purpose-built AP for it. AFC systems generally are going to be coordinated through your controller. They run a AFC check every 24 hours. It requires coordination with GPS. If you do not phone home, or if you not successfully phone home in 24 hours, I believe it's something like you have basically an age out of another day, and then the AP gets kicked off. But typically it's a fairly clean and simple process, at least as I've seen so far. ComSearch, I will plug, this is our sister company. It is one of the 13 or so approved providers by the FCC. We have this baked in to our controllers and our APs. So if you buy a Ruckus controller that supports Wi-Fi 7, it will have ComSearch support built in, and that is your AFC provider. Channels may be LPI only or have different power levels depending on the mode. We talked about that on the slide deck before, or the slide before. So you need to understand your channels. If you're putting it outdoors, you're never going to be on an LPI only channel. It won't work. So another way to look at it, again, just to understand part of the 6 gigahertz, why we need AFC is we have incumbents that have a lot of fixed microwave links. So we need to avoid them. We need to coordinate to make sure we're not going in and interfere with them. You've got some that are standard power controlled. You've got the LPI, the Uni 6 and Uni 8 that are LPI only. LPI is across the entire spectrum, but standard power is not. And there's your power. Different power levels based on what you're trying to do in that spectrum. So same as we used to see with DFS versus non-DFS channels and Wi-Fi and 5 gigahertz, there are different power levels that we have to take into account. And again, this is a rabbit hole we can definitely go down, because this gets into RF math. This gets into, are we using an intentional radio? We adding an antenna? What's the gain? All that has to get factored in, and you cannot exceed certain thresholds. And while this is targeted for people in North America, it's worth saying, anybody that's watching this in Europe, this doesn't apply, because different rules, not the entire spectrum yet in place in Europe either, if I recall correctly. So it's a lot more to learn. There's a lot more to get into. And this is another reason why I think we're going to be leaning on AI a lot more to help us keep things clean.
Yeah, when you start talking about that much spectrum, right? That's a lot of spectrum, and in different devices at different powers that can transmit across different chunks of spectrum. Like the power spectral density becomes very important, because your actual amplitude or power varies based on the actual used bandwidth, right? So it is a rabbit hole, and it's one, even the telecom providers deal with, because we have to understand power based across the power spectral density, because certain devices have to be optimized. If you underpower them, then your signal quality will be poor. If you overpower them, then you'll have distortions and artifacts and compression and other things. So understanding, your power to spectrum relationship is important to get the devices running at their optimal performance. And it doesn't have an impact on signal quality too, which in this context also means speed.
Yep. And it's one of those things where I didn't drop this analogy before, but I kind of try to convince people, if you're not used to Wi-Fi at all, think of it like a speaker system at home. Everybody loves it loud, right? More power. But what happens when you overpower that speaker?
Distortion.
Exactly. And Wi-Fi is a similar thing. And I had this conversation with, even when I was in my infancy of learning it, you can overpower the Wi-Fi. People with like home devices, home routers, you look at the settings, they just crank the power to like 11. And that seems like it would be great, but it's actually not. You know, Wi-Fi likes to actually be low powered, real quiet, just powerful enough. You know, when you're dealing with a corporate deployment, an enterprise deployment, I mean, I could put 40 or 50 on a floor, and that might seem like a lot, but I want to have a small cell to cover a certain area, and I want to make sure that that AP is only heard by a couple APs, not the entire floor. So it is possible to overpower it, but power, that gets into the real fine tuning of it, which is, again, that's a whole nother topic for conversation.
Yeah, this isn't alien to us either. Like, we deal with quadrature amplitude modulation and, you know, 4K QAM or, you know, QPSK or 1664 all the way up to 4096 QAM in OFDM and OFDMA. You know, we understand that there's accuracy in the transmission of the bits inside the decision boundary and, you know, the I and Q vectors. Like, signal quality is super important, and that goes back to power. If you're overpowering it, then, you know, you start to have bits that fall outside the decision boundary, correctable FEC rates, failed FEC, retransmissions, packet loss. You know, all that comes down to the customer experience. It's a lot of similarities in, you know, data packet transmission.
Yeah, no, agreed. I looking at this chart on the screen is a good way to kind of talk about it too. This is going all the way up to where we're heading with the 4096 QAM or 4K QAM, you'll hear it called. The upper left corner is basically early low-end Wi-Fi. It's really easy when you're only trying to hit 4 quadrants. It's really easy to get the dots to all kind of be where they need to be. But when you start making smaller groupings and more of them in the same quadrant, it gets a lot harder. And this is one of the reasons why we always say, you know, it's really important to be closer to the AP. That's 4K QAM on the right there right now.
Yeah.
And so, you know, yes, I could sit at an AP or I could connect to an AP that's 50 or 100 feet away, but it won't be great. One of the things I always stress to people that are sort of learning it is, you know, you see the marketing numbers, that 46 or whatever it was, 46 gig. You're only going to get that in a particular environment, you know, in a vacuum, in a clean lab, on a particular set of hardware, on a particular AP set at like max power, plugged in with nobody else around and zero interference. It's unrealistic. It's not real world.
Yeah.
That doesn't mean you can't get some really good performance real world, but you need to make sure it's a clean environment. You've got a good handle on what your devices are, but your devices and your APs are in close enough proximity. You're not putting your APs like 30 feet up in a ceiling behind a metal mesh drop ceiling, which, yes, I've seen done before. You're putting it where it needs to be. And you're making sure that there's enough to go around to support the client density and things like that. And then the higher levels of QAM get to be achievable. But this is why the further you go away, I mean, it's the rules of, I'm going to screw up the rule, but basically every 3 feet or 3 meters, I'm going to screw that up. Somebody's going to kill me for that. You lose half, right? You lose half the power. Yeah. And the signal drops. So it's physics, and I didn't do well in physics, but it's physics. It's not somebody saying that as a joke or a gag or just making it up. It's legitimate physics. And that's how all of the design tools kind of work. That's how they work. They are all driven by those legitimate rules that we know.
We call them laws. Like they're not suggestions of physics.
Exactly.
They're laws. You don't have to like them. You just have to understand them.
Exactly. So with that in mind, a couple more things, and we're almost near the end of this. A couple more things to highlight that Wi-Fi 7 is bringing out. Again, just scratching the surface. Punctured transmission is another one I love to talk about. We talked about in 5 gigahertz, excuse me, where you've got that one client using 80 megahertz wide, and then you've got somebody else who's on a 20 megahertz wide that's interfering, and therefore you can't use that full 80. You can only use 40, and the interference gets the rest. Kind of sucks. Your 40 megahertz wide channels are still good, but you're losing performance. In Wi-Fi 7, you're going to get punctured transmissions where you're still getting that first 40, but you're also getting that last 20 that wasn't getting interfered with, because that's just how it works now. The punctured transmission is going to be, I think, a really big boost, especially in congested environments like we saw in that example, where there were a lot of instances where you might see a punctured transmission take place, therefore allowing everybody to function a lot better. Still waiting to actually test and play with that, but that looks really, really promising. Multi-link operation is another one. I actually should have brought a different picture for this one, but the idea is you could have your device connected to the network on 6 gigahertz. It also has a 5 gigahertz radio, so does the AP. If, for whatever reason, the 6 gigahertz link gets disrupted, it's going to just send the traffic over the 5 gigahertz. Potentially the 2.4 as well, depending on the configuration. Again, this is still being learned about in real world exercises, but it's supposed to be, and we've tested this in the lab, giving you a more reliable, think about almost like link backup, really. Giving you multiple links running at the same time to get more throughput and more reliable throughput. So instead of being on one radio, losing that signal and having to wait for the next radio to pick up, it's seamless. So in the lab testing that we did, you see just standard operation on one radio, and you see the peaks and the valleys. With MLO, it's locked in steady at a hard and fast, flat line at one, whatever the throughput was for the entire session. And it was across the board consistent, and it was just really nice to see. But again, this is something else that's coming with Wi-Fi 7 that we're just starting to see as the devices hit the streets. A lot to be excited about here as well, and I think there's going to be plenty more to talk about, and there already is actually.
Yeah, as operators, I think that MLO is going to be huge because of the perception of reliability. Going back to your experience with your laptop changing channels, right? If you didn't have that indicator that told you that you jumped to a different radio, if you didn't feel it, then you wouldn't have noticed it, right? And that comes down to, as operators, the customer's perception of reliability is reality, whether it was the network or not. So having that seamless transition is going to be a huge benefit to the operators as we kind of move forward into Wi-Fi 7. The other one is that punctured concept, where we have something today in our OFDM deployments. Some operators have some profile management applications that allow, this big block of spectrum, 9692 megahertz wide. If a portion of it's impaired, it can downgrade the modulation profiles of that particular portion, but let the remainder of the unaffected channel, based on its signal to noise ratio, run at a much higher data rate or higher modulation rate. So there's a lot of really cool kind of parallels to that technology as to traditional DOCSIS technology. So there's a really cool marriage, and I appreciate you taking the time, John, to run us through this deck. I know we're way over time.
No, it's fine. I appreciate it. I'm happy to do it. It is cool. I think at the end of the day, this is the evolution and the maturation of Wi-Fi. You mentioned it a lot. There's a lot of parallels with DOCSIS. I think there's a lot. I'm not a cellular guy, but I've worked around it a little bit. I think the people that put this together, the learning groups, the working groups, have learned from other technologies that have better management of the spectrum and the resources available. And I think we're imparting that to Wi-Fi, to where, Wi-Fi 7 is called extremely high throughput, but with things like, puncturing and MLO, I think we're not only seeing extremely high throughput, but we're seeing extremely efficient use of the spectrum, so that it's going to be a lot harder to make it a complete mess. It's going to be a lot better for everybody, because at the end of the day, it's hard. You can't police the spectrum. It's shared. It's an open resource. Nobody owns it. It's not licensed. So as long as you behave within the FCC rules, I can't go kick you off legally. Yeah. So we have to behave better. And this is one of those things that I think it's going to serve us well for the future. I know in a couple of years I'm going to be talking about Wi-Fi 8 anyways, but I think Wi-Fi 7 is going to be around for a long time and get a lot of use, because again, like I said, the original Wi-Fi still works today, and I'm sure in 25 years Wi-Fi 7 devices probably still will too. So I'll leave you with this. There's a couple resources we can share. If anybody's interested in learning more about Ruckus and Ruckus education, there's our Ruckus Network's training and certification site, as well as our YouTube channel. The podcast does have some videos there as of this year, where we actually have some faces to be seen and slides to share. The Ruckcast is the podcast that's on the YouTube channel, as well as the channels that Michael mentioned at the beginning. Jim is my co-host on the podcast. Jim Palmer has a good blog that he doesn't update as often, but if you're looking to learn Wi-Fi, he's got some good basic stuff there as well, but he does do a lot focused on Ruckus as he learned it. Non-Ruckus, Clear to Send is a really good podcast. They get into the weeds of all things wireless. And if you're looking to learn and get certified about Wi-Fi, and this is how I got my CWNE, the CWNP program offers things from CWNA and below all the way up to CWNE. So that's a good resource to look at, spend time at if you're looking for professional training. Strongly recommend it. And then again, there's also a WLAN Pros. There's a group, they run conferences a few times a year where we all get together and a few hundred gather in Arizona or Prague or elsewhere and nerd out about Wi-Fi for a week. And they do some trainings as well. So it's pretty cool. And they have a Slack group, and you'll find us all over social media.